So we have, today is the 20th. So we have a given function, which is 3x squared minus 5x plus 2. And we're asked to find and simplify the difference quotient. Okay, here's a difference quotient. You do not have to memorize it. It will be given to you. However, I think it's not such a big deal once we understand what it is to remember it, but it's okay. You will be given this. Okay, so I look at the difference quotient and I see basically three different pieces. Which of these pieces I cannot do anything to? Which of these pieces I cannot do anything to? The age I cannot do anything to, and what else?
And then x plus 8.
Oh, I have so much work to do on that one because I don't have it. That one is not given to me and I need a lot of work on it. Good, so how do I start? Where is the starting point? Yes, so in order to find f of x plus h, so I have this and I have this. This is the only one that is more involving and I don't have it. So f of x plus h equals, and in parentheses, x plus h squared minus 5x plus h plus 2. What do I do next? It's the order of operations that I'm worried about now. And how do I proceed? So I have to square first. So I have 3, and then? Very good, plus 2xh. We have an agreement on that. So please make sure you remember that. And plus, very good, minus 5x minus 5h and plus 2. And now, of course, I have to distribute 3. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 2. So that is only this. So now the difference quotient, the numerator, this has to be replaced by all this. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 2. I only copied it. And then what do I have to write? Minus 3x squared plus 5x minus 2 over h. Now, two things have to happen. Otherwise, I made a mistake. What are those two things that have to happen when I calculate or determine or simplify the difference quotient for any function? Two things must happen. You have to have that in the back of your mind.
Anything without an h.
At the top, have to cancel out. One will be positive, one will be negative. Awesome. And what is the second thing that must happen?
The h on the.
Yes, this one somehow has to go away. The final answer will still have h in it, but not this one. Very good. So do terms go away? Because if they don't, then we made a mistake. Yes, you cannot cross them out unless they are opposite terms. Right, if I see here positive 3x squared and positive 3x squared, I will not cross it out. I cross it out because one is positive and one is negative. Agreed? Okay, so then the positive 5x with a negative 5x and a negative 2 with a positive 2. Now I have to count the terms I have left at the top. How many terms I see at the top? Yes, so those 3 terms have a common factor. I have to pull it out. And that common factor is, it must be, because remember, we already know what is going to happen. We know that these 2 must go away. If there is not one out here, I will not be able to get rid of this one. Okay, so what is left? Since I counted 3 terms, that's why I counted them, because I have to have 3 terms here, not 2. Some of you, very few, however, put only 2 terms. You can't do that. So that's why I counted them. 3, 3. Yes? Yes? Yes. Now I'm ready to do this. If you don't write 1 and 1, you may think it's 0. I've seen that too. So please be very careful. Why is this so important? It gives the rate of change of a function at any point. That's why this is so important. Good. Next question, please. Yes, Damon, go ahead. Yes, 1 second. Damon?
I'm canceling everything that has an H in it, right?
That does not have H in it.
Don't have H.
It's a positive 3x squared, negative 3x squared, positive, negative 5x, positive 5x, positive 2, negative 2.
Okay.
Some terms with H may go away, but definitely the ones without H must go away.
Will go away.
Yes.
And then I'm bringing the other one.
Then we have to pull out an H. I count the terms at the top.
Right.
I see they must have an H in common because they all still have H.
Right.
So I factor out H. I still have 3 terms in parentheses, and that H will simplify with the H in the denominator.
So the H that you take from the 5H, you use that and break it down to use for cancel.
Yes, because H times negative 5 is negative 5H.
Okay.
And H times 6x is 6xh. And H times 3H is 3H squared.
Okay.
Yes, please.
Function of X.
Say it again. Oh, so you want to find the difference quotient for 9 over x. Very good. Very good. So let's do that. So we are given a function which is 9 over x. And we want to find the difference quotient for this function. Of course, the same definition, f of x plus h minus f of x, everything divided by h. It's a different, yeah, it's not here. It's not here, it's from my math lab. So that's very good for those of you who did not get to that step. It's a very good question. Perfect. So what do I do now? Again, I'm going to ask the same question. What do I have, sort of, and what do I have to work on? I have f of x. These are the 3 pieces that I'm looking at. It's not about x here. It's about this piece, and this piece. From these 3 pieces, what do I have to work on? Exactly. I have to work on f of x plus h. These I can do anything to. So in order to find f of x plus h, can anyone dictate?
9 over
Yes?
X plus H.
Very good. Do we agree with this, everyone? Yes? Okay, perfect. So now I put all 3 pieces together and try to find and simplify the difference quotient. Ready? So then the difference quotient, I write f of x plus h minus f of x divided by h. And now I replace this by 9 over x plus h minus this by 9 over x over h. Good. Where is the starting point? What do I have to find next? What do I do? Where will you start? There is nothing I can do to h. This is so simple that I can't do anything to. So if it's not here, where do I have to start then?
9x.
The numerator. I have a difference of 2 fractions, right? There is nothing else. I can't do anything. I just have to find that difference. Good. So how do I find the difference of two fractions?
Plus x equal to x plus h.
What do I have to find in order to subtract or add fractions that do not have the same denominator?
They get the same denominator.
Find the least common denominator. Very good. What is the least common denominator?
X equal to x plus h.
Yes, they have nothing in common. There are two different factors. Both of them have to be in the least common denominator. Mandatory. If there were three factors, all three would have been in there. Very, very good. Thank you. So now the question is adjustments. I cannot write 9 minus 9. That will be a terrible mistake. So what is the adjustment for the top of the first fraction? What it does not have in the denominator. If the denominator is x plus h initially, and it is multiplied by x to get this, I have to do the same thing to the top. X. So what do I have? What is the adjustment for the top of the second fraction?
X plus h.
X plus h, exactly what it does not have in the denominator. If I took the liberty to multiply x by x plus h, I have to multiply the top by x plus h. So now can anyone dictate the numerator of this fraction at the top? 9x, very good. Minus 9x
Plus h.
minus 9x. Say it again.
Wouldn't that be plus h?
So it's negative 9 distributed to x, and you said negative 9x. Now it's negative 9 distributed to h. Minus 9h. Yes, Jesse, you had a question? Go ahead.
I did, but I think I got it.
Okay, very good. So what happens next? Yes, because they are opposites of each other. Good. What now?
Plus 9.
This is, I am now in the position of dividing two fractions. Finally. How do I divide two fractions? As you see, the terms without h went away, as expected. Yes, so I copy the numerator. Very good. And what do I do next?
1 over h.
That's it. And this is the second thing that has to happen. What is it?
H.
Must, yes, because it's already factored. So what is the simplified form of the difference quotient for the function you gave me, which was 9 over x?
Negative 9 over x minus x plus.
That's it. This is it. This is the difference quotient of the function you gave me, 9 over x. Very good. Next question. Yes. 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 That was the second question. I think, I'm not sure who asked about that. I forgot. Okay, so what was it? X squared minus 8x plus 10? Okay, equals 0. Yesterday, one of my students said this when I solved the different complete the square problem. She said, when I asked the question, what do I have to do first? She said, move 10 to the other side. And I said, why? Why would you have to do that first? And she said, well, when I put the 16, when I put the number that I have to add to both sides, I am tempted to combine it with 10. So I learned something yesterday, and I always learn from you too, and I think it's a good explanation. She said, I want to get rid of that 10 because it may be tempting for me to combine it with something else. So let's do that first. If that works for you, that's fine. So now the method of complete the square has 4 steps. What is the first step? Identify the middle coefficient. What is the middle coefficient?
No.
The middle coefficient is? Thank you. Step number 2. We divide this number by 2. What do we get? Very good. Step number 3. what do I do to negative 4?
I did.
Good. So I square negative 2. What do I get?
I did.
Wait,
That's 16.
I'm sorry?
16.
Yes, I have to square negative 4 and I get 16. And in step number 4,
You add it.
that's it. I add 16 to both sides. So x squared minus 8x plus 16 and negative 10 plus 16. If you do not add it to both sides, you are changing the problem. And you're not solving the correct.
Okay, so step one was take out the negative 8, right?
Identify the middle coefficient, then divide it by 2, and then square it.
Okay, that's right.
Good. So then the left-hand side becomes
Square x squared at x squared.
we have a contract on this.
so it's gonna be x minus 4 parentheses.
Thank you very much. Equals?
6.
Very good. If you remember, we said complete the square will not solve the equation. What would be the next step now?
Square root.
Exactly. Apply the square root to both sides. How many solutions do I expect to get? So please remember that question. So please tell me what to write.
Plus or minus.
X minus 4 equals,
Some 4 square root of 6.
I find this again. Don't you move that 4 to the other?
it's squared.
Plus or minus square root of 6.
Ah, that's it. That's all I wanted. So then x equals?
4 plus or minus.
Very good. This is it. Any questions on this? Any questions? Harry, you have these two?
Hmm?
You have the previous?
I'll pay off my stuff at home, I'm sorry.
Okay, next question, please. Anything else you would like to go back to?
I have one.
Which one?
It's on the breaking paper. It's D.
Just 1 second. I had, yes, here it is. We just solved a difference quotient problem right before you came. So it's this one. So if you have any questions, I'll be more than happy to go back at the end of the class, Harry, on this. Okay, what am I doing now?
It's on the breaking paper and it's letter D.
So it's D in 1D? 1D? Yes, okay, very good. So let's look at 1D. Is this the one?
Yes.
Perfect. So we have x to 2/3 minus x to 1/3 minus 6 equals 0. Whenever you give me, or I have to solve an equation, for example, like in this case, my first thought is, my first question to myself is,
What type of
exactly, what is this? What am I trying to do? What is this equation, first of all? What type? And things go through my mind. Is it linear? No. Is it quadratic? No. Is it radical? No. Is it rational? No. Is it absolute value? No. So I'm really literally down to the last option. What?
institution?
Exactly. Quadratic in form. Yes. Quadratic in form. That's why I mentioned to you, and I kindly ask you to do that, and this is going to work for you very well in all your classes. A little notebook in which you summarize things that you learn every day. I learned how to solve blah, blah, blah. What is a quadratic equation in form? Oh, I can replace it by another equation. It's not quadratic, but I can replace it by a quadratic equation. And then I can use substitution and all these things, and it will really help you. In all your classes, this is what I would do. Because you need to practice. What I I was very lucky. I think I had a wonderful grandma, and she would make me summarize what I was learning and then summarize the summary in a different notebook. So I think that's the way, I guess, she was taught, or that's the way she taught students. She was also a math professor. So I'm not sure where that came from. I'm not sure how but that's what she was making me do. So invent something that works for you. If my suggestion is, doesn't help you, just invent something else, or talk to other people and ask them, I see you're very successful. How are you doing it? What is the method that you apply to remember this and remember that, and so on and so forth? Okay, so quadratic in form. Yes, when we say quadratic in form, we are thinking of a substitution. And which of these two will I look at and consider, let's say, let y be? Which one? Yes, x to 1/3. Why x to 1/3? Why will I consider this to be y and not this one?
Because the first one is y
Squared, exactly. So I have to be careful because these terms may not be arranged the way they are now. It's very clear power 1/3 is much smaller than power 2/3. So it's actually double, right? So I always have to look for the smaller power. So x to 1/3 is smaller than x to 2/3. I mean, power 1/3 is smaller than 2/3. So then, how will you replace this? What will the new equation? How will the new equation look like?
y squared
Yes, minus y minus 6 equals 0. Now, you can say, I don't care for your substitution. I know how to factor this directly. That's fine. It's fine. If you want to, if you can factor this directly, it's fine. Forget about my substitution. But I think in certain situation helps. The substitution will be easier for you to factor, or it will be a helpful step. If it isn't, go directly to factoring. So now this should not be difficult to factor. How do I factor y squared minus y minus 6?
y minus 3
Very good. So then we have two options for y, and the options for y are? Good. Is this done? No, because we only solved for y. We did not solve for x. So we have to go back and solve for x. So now let's solve for x. So y equals 3 really means what equation?
x raised to power 2 1/3.
Very good, equals 3. And then y equals -2. What equation does this mean?
X raised to power 1/3.
Equals -2. Now I have to dig deep. What type of equations are these? Linear, no. Quadratic, no. Absolute value, no. Quadratic in form, no. Rational, no. So what are they? So I know what to do next.
Squared.
I have to do what?
Squared.
Square will not work because it will not be
Sorry, cube it.
cube. It's a radical equation. Power 1/3 is the cube root of x. So in order to eliminate power 1/3, I have to cube both sides. Exactly. Is this clear? Okay, so we have one more step. X equals
27
27, and from here x equals,
minus negative.
good. Do I trust this? No. No, I don't. So in y equals, I already have this function put in. because your colleagues from earlier, they asked me the same thing. In y equals, I have x to 2/3 minus x to 1/3 and minus 6. So what am I trying to see? I want to check. I have to check because I cubed both sides. When I cube both sides, the solution should work. When I square, they may not. But I want to check. So what am I checking? What do I plug in?
27.
And after that, I plug in
Negative
-8. And what should the answer be?
0.
Exactly. So second and table. When I plug in 27, I get 0. When I plug in -8, I get 0. So then what do we conclude about both solutions, -8 and 27? Do they work? Are they acceptable or not? Of course. They are accepted and they work, of course. Yes. Good. Next question, please. Say it again. Yes. So you want to look at the yes. Which form was that?
The last class.
Yes, I know, but which? Yeah. So let me see which function was it. Okay, so it was 3x plus 6 for x less than 1. So let's take a look at the piecewise defined function. Yeah, some of you had some difficulties with it, so it's a good. I would have chosen a piecewise defined function anyway. So f of x was, it's negative 3x plus 6, is that correct?
3x plus.
Okay, for x less than 1.
Yes.
And the square root of x for x greater than or equal to 1.
Yes.
Is that okay?
Yes.
What problem is that?
From the classwork last time.
That's on
Yeah,
the
we
other
have
sheet,
it.
the white sheet.
Yeah, that's fine. So let's look at the other problem. Good. So I'm asked to graph a piecewise defined function. Like before with the difference quotient, when I reviewed with you, what do you expect to happen when you find the difference quotient for any function? And you said clearly the top terms with no h must go away, and eventually the h in the denominator must go away. The same thing, type of prep, I'm going to ask you here. What has to happen when I graph a piecewise defined function? So on some x values, I will have a graph that cannot be extended to your left, to your right. Okay? On the other side, I will have a different graph that cannot be extended to your left, right? The first one cannot go to your right. This one cannot go to your left. If you graph something like this, is this a function? No. By the vertical line test, this is not a function. So be very careful when you graph something like this. One side cannot overlap on the other or go or be extended on the other side. Is that clear? Okay, perfect. So now the next step is I will identify the interval notation. Many of you did this very well, very nicely, very clear. There were no discussion. I couldn't ask a question. I could have not done it better than you did. So what is the interval notation for this? Negative infinity to
No, I said positive. Is that wrong?
x smaller than 1. Which side is x smaller than 1? This is 1. Which side is smaller than 1? This way or that way?
Negative.
Right. So from negative infinity to 1 is smaller than 1. Good. So negative infinity to 1. What about the next one? Very good. So it's 1 and to the right-hand side of 1. Now look at these two intervals and identify the domain. Every time I'm asked to graph a function, I have to start with a domain. So what is the domain of this function?
Negative infinity to infinity.
Do you all agree with that? So negative infinity to 1, 1, and everything between 1 and infinity. Agreed? Questions? Is this okay? Very good. So that's how I start. Negative infinity to infinity, and this is f of x. Which x value must be in the chart no matter what? 1. Why? What happens at 1? That's where the graph may, I don't know yet, may break, where this side cannot be extended this way and this side cannot be extended that way. So, of course, 0 has to be in the chart as well, but 1 is the key. Exactly, yes, Damon?
The square root of x, we didn't get that part yet, right?
No,
Okay.
in a moment.
So, okay.
So right under 1, I will have these two symbols. The parenthesis opening this way and a bracket opening this way. And they have to touch. And they have to be exactly under 1. Not left, not right, immediately under 1. I'm going to ask you a question now. I know it's an overkill, but it's better to see it and put it in there. These two branches may not be given in the correct order. So that's why I have to be careful when I write what I need to write. So for x values between negative infinity and 1, which particular function, which piece, which branch will I use? Indeed, 3x plus 6, because negative infinity to 1 is specifically made for 3x plus 6. Perfect. Although this is clear now, please, can anyone say between 1 and infinity, which function do I use? Very good. Square root of x. What type of function is this?
Linear.
Perfect. What type of function is this?
Square root.
Square root. So please remember, we had that long list of base functions. You cannot graph this as a line. Many of you graphed it as a straight line. No, it's not acceptable. This is not a straight line. Be very careful. Okay, very good. So for the linear function, like for everything, I always look for the x and y intercepts. So when I plug in 0, what do I get here? 6. What happens when I plug in negative 2? Exactly. So try, if possible, it happened that negative 2 and 0 are between negative infinity and 1. If this would have been 0 at 5, I cannot put 5 here or 5 here, right? Good. So now please plug in 1 and tell me the answer. Yes, it's right in here, not away from the parenthesis, inside the parenthesis, so you know what's happening there. Now on the other side, please plug in 1, and then of course plug in 4. When I plug in 1, I get, and it has to be right here inside the bracket. And when you plug in 4, what do you get? Right. So now I'm ready to graph this function. From left to right,
Where'd you get the 4 from? I'm sorry. You just pulled out.
the square root of 4.
No,
I need
no,
to
where'd you get the 4 from to start it off?
Next value.
Oh, you just made it the x value.
Because it's square root.
Oh, you just wanted the square root. Okay.
Yes, yes. I chose 4. I could have chosen 5, but I can't plot that. It's more difficult. Good. So from left to right, can anyone give us the first point that I have to plot? One more time. One more time.
Negative 2, 0.
No problem. Next one.
0, 6.
Next one. What type of point is this?
That's the max.
Being open.
It is an open point. Why is this an open point and not a full point? Because of the parenthesis. I'm not allowed to plug in 1 here, but I have to plug in as close as possible to 1, which is 0.9999999. I can do that. I'd rather plug in 1 and leave it open. Some of you extended this line to the right, and that's my point. At 1, the left-hand side is a graph, and the right-hand side is a different graph. You cannot extend this to your right. You cannot extend what we have going to right, graph on the right to the left. That's the way a piecewise defined function works. If you do extend it, it's not going to be a function by the vertical line test. So then on the other side, what will you tell me to plot first? Good. And then it's a full point, right? I should have asked that before plotting it. So my graph is not perfect. So I went a little bit too far. Okay, so this has to be exactly, you don't have to graph this. I'm just pointing out that they have to be one under the other. And then 2, 3, 4, 2. And if you graph it as a straight line, I have to deduct a little bit because it's not a straight line. So the square root is this portion. I'll spend we can do another one at the end of the class or with you after we finish because we have so much more to review. Yeah, no, that's okay. Do you have some time after class? Are you going to run? Okay, so we'll work on another problem together, okay? I'm sorry? That's good. Good. Next question, please. Other topics. We'll go back to another piecewise defined function at the end if we exhausted all topics. Yes, please. Yes. Oh, individual question we have to talk about. So it doesn't start here, it starts here, and it's this way, and that one is this way. So we can talk about it at the end. Individual question at the end. Yes. Yes, next question, next topic, please. Yes, please, Kelsey.
Can we do egg number 3 on the left-hand packet?
Yes. Yes, very good. So let's do that. So we are asked to determine the equation of a line that passes through -2, 3 and is perpendicular to 2x minus 5y equals 7. Is that correct? Is that the one? Perfect. So what is the first step here? Yes. So what I'm suggesting is what I do in this particular situation is I give a graph, which is not an accurate graph of anything, but just to give us the idea. So let's say I have a line whose equation is unknown, and I know two things about it. This is the first piece, and this is the second piece of information. The first piece tells me that somewhere along the line, I find this point, or if you want, the line passes through it. Fine. Then I have the second piece of information that says that there is a line that is perpendicular to the one I don't have, whose equation is 2x minus 5y equals 7. And knowing all these two pieces of information, I'm asked to find y, like in the form of y equals. So is this point, first of all, I'm asking myself, is this point the y-intercept? No, because it's not 0, a number. So I cannot use this because I don't have b. What is the other alternative? Yes, exactly. Y minus y1 equals the slope times x minus x1, in which x1, y1 is basically the point, right? So this is -2 and this is 3. The only thing that I'm missing here is the slope. But is there a way of finding the slope knowing that there is a very important or clear, if you want, relationship between the slopes of two lines that are perpendicular? Is there a relationship? Do we know any relationship? If this is slope m1 and this is a slope m2, is there a relationship between the two slopes?
Yeah, it's a
Negative reciprocal of each other. Awesome. So then maybe there is a way of finding the slope of the green line. Because if there is a way, then I can find the slope that I'm interested in, which is this. So what should I do? Yes, I have the green equation. What do I do to it? Exactly. That's the Perfect answer. I have to solve for y. If I solve for y and I put it in this format, then the slope or the number, not x, but the number in front of x or the coefficient of x will be the slope of the green line. If I have the slope of the green line indirectly, I determine the slope of the unknown line. Okay, so let's solve the green equation for y. So the first step would be to 2x, yes, negative 5y equals negative 2x plus 7. Notice that I arrange it already in the correct order, because who knows what I'm going to do next if I can identify something else. Okay, and then what do? I have to divide by negative 5, perfect, term by term. Do not just write here negative 5. No, please. Negative 5 divided by negative 5 is 1. Negative 2 divided by negative 5, is it a positive number or a negative number? Very good, 2/5 x. And then 7 divided by negative 5, is that a positive number or a negative number? Very good, awesome. So I have the slope, what I'm going to call M2. What is the slope of this auxiliary line, given line? 2/5. Therefore, I know what M1 equals to.
5 halves.
The product is 1. 5 halves will not work. The product cannot be 1.
Negative.
Exactly. It has to be negative 1. So
Negative 5 halves.
that's it. Remember, it's the negative multiplicative inverse. The product must be negative 1. Good. So now I have everything I need. So y minus 3 equals negative 5 halves x plus 2. Do we agree with this step? Y minus 3 is here. I replaced m by negative 5 halves, and then x minus minus 2 is x plus 2. Could you follow so far? Of course, I have to distribute, combine like terms, move 3. So I'm distributing. Negative 5 halves x. And now perform the operation negative 5/2 times 2/1. Always simplify first. Negative 5. And now I have to bring a positive 3. So final step. I owe you $5 and I say to you, Heather, I only have 3 today. Very good. Can anyone explain what this equation represents? Or say one sentence. This is the equation that, right, but how did we get it? What does it represent in the context of the problem? Is the equation of the line passing through
Negative 2, 3.
negative 2, 3 and to the given line. Very good. Is this clear, Kelsey? Okay, anyone? Questions, please.
Please tell me, question 5 on the thing.
Okay, very good. So is this function symmetric? We have f of x equals 5x cubed minus 6x.
Excuse me, on this.
Oh,
Simplify the expression for you.
yes, let's do that. 2, x minus 3 cubed times 3, 4x minus 1 squared minus x minus 3 to the 4th times 3 times 4x minus 1 times 4, everything divided by 4x minus 1 to the 4th. Very good.